Hello friends and welcome to another tutorial on Geeks for Geeks. In this video we are going to understand the program that remove nodes on route to leaf path of length less than k. First, let us take an example. In this example, if we take k as 4, we have to remove nodes on path less than 4. There is only one path which is 1, 2, 5 and node 5 is the only path that lies in this path, so it will be removed. Now let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node and k to function remove short path nodes. Let us assume that k is 3. We take a path length variable and initialize it to 0. Next, we call the remove shortest path nodes util function with root, 1 for level and k passed as parameter. Since root is not pointing to null, we traverse the tree in post-order fashion so that if a leaf node path length is shorter than k, then that node and all of its descendants till the node which are not on the some other path are removed. So we pass the left child of 1 which is 2 along with level plus 1. Since root is not null, we further pass the left child of 2 which is null along with level plus 1. So now root will be null and level 3. As root is pointing to null, we return null and resume execution for node 2. Now we pass 2's right, so root will point to 5 and level will be equal to 3. Again, as root is not null, we pass the left child of root which is null. Since root is pointing to null, we return null. Next, we pass the right child of 5 which is also null. Again, as root is pointing to null, we return null. Now we check if root is a leaf node and if its level is less than k. We delete the node. Now 5 is a leaf node but level is not less than k. So the if condition doesn't get satisfied and we return root. Execution for node 2 is resumed and we check if 2 is a leaf node and level is less than k. Since 2 is not a leaf node, the if condition doesn't get satisfied and we return root to the previous call. Execution for node 1 is resumed and now we pass the right child of 1 which is 3 along with level plus 1. As root is not pointing to null, we pass the left child of 3 which is null. Now as root is pointing to null, we return null. Next, we pass the right child of 3 which is also null. Since root is pointing to null, we return null. Now we check if root is a leaf node and level is less than k. As 3 is a leaf node and is less than 3, the if condition gets satisfied and we delete root. Then we return null, so 1's right will be null. We resume execution for node 1. Now as 1 is not a leaf node, the if condition doesn't get satisfied and we return root which is 1 to the caller function. Hence, this is the final tree. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.